we'll go ahead. So our last talk of the first half of the second session is going to come from Della, who is from ZONTAL, and he is going to be talking about ZONTAL Application Hub and how it's using Allotrope data format, ontology models, and simple models to do that. So Dennis is a professor at BYU University. He also serves as the Chief Science Officer at ZONTAL. He's the Director of Consortium of Molecular Design at BYU. His research applies artificial intelligence and advanced analytics in fields of protein engineering, drug discovery, augmented pathology, and laboratory information. So Dennis is going to be joining us virtually today. We can see you there. Are you? Let's go ahead and we can check your mic and get the presentation set up, and we can get going there.
Thanks for the introduction, Corey. Then thanks again for having me. I'm sorry that I can't be with you in person. I believe my first Allotrope Connect in 2016 was in Philadelphia, and I enjoyed this office of Drinkable at that point quite a bit. And it was also the first meeting where I met Wolfgang Kurzmann, the CEO of ZONTAL, and we kind of kicked off a collaboration that's still ongoing. So I'm pretty excited to be again with you and talk about some of the great updates we have made within ZONTAL, within our application and product hub that leverages quite a few of the outputs of the Allotrope Foundation and different members that we have there that we have worked with. So it's always a good meeting to be at. So the title of my talk is From Chaos to Clarity. And it's sort of the result of asking ChatGPT to pimp up a title for an abstract that you're not happy with. So,
I knew you.
Yeah, for whatever it is, that's the talk of today, the title of it. I will be talking about different solutions that we have that are all geared towards one aim, and that is to help people make better decisions. Because I believe that the core of all of our roles, no matter what the scope of responsibility is, we all have to make decisions. But we are not always sure if the decisions that we are making are a gut feeling or if they're really data-based and if they're factual and represent, the best possible outcome for our stakeholders. And so I found a very interesting graph I wanted to share with you that comes out of a paper in Drug Discovery Today by Bender et al., where they looked at the different phases of the drug discovery and development process and asked the question, what if we would decrease, either increase the speed or improve the quality or reduce the cost of any of these phases by 20%, what would be the impact on the bottom line of the cost of the entire drug discovery and development process? And so when I studied this graph, I was quite, it's quite interesting to think about it. Sometimes you overthink certain lead optimization topics maybe, and you try to speed up things where speed doesn't really matter yet, or you try to improve quality at areas where the bang for the buck is quite not what you intended it to be. And so studying this, I realized that there are quite a few decisions that we have to make, that our customers have to make, and the people we work with, depending on where they are. And even though maybe in the large scheme of things, they correspond to an improvement in the small millions only, down the road, they can lead to substantial changes in the baseline if the data that is being collected in these processes is leveraged appropriately. And so I think some examples of questions that we might have to ask, especially if we work in a laboratory, are things like, I'm having a new question. Is this a question that's new, or has someone done an experiment like this before? And if this has been done by someone else, can I get access to the data set somewhere, and can I trust the data set? And then very often, and that's one of the reasons why cost, especially in certain areas, is so high, the question comes up, can I trust this data set, or do I need to go back into the lab and repeat things? And I think one of the worst things we can do is repeat work, create something that was already there. It's not giving us anything new, but we think for some reason we are compelled to do it because it's just too hard to get the information otherwise. And so questions like that are things we want to have our customers be able to make clear answers to. Should I do this again? No, yes, why? And then be able to give very good arguments that are factual and data-based. One of the most important questions, I would say, looking at this graph is after clinical phase 1, should I continue? Is there a reason to take a molecule into phase 2 or not? And we can see if we can improve that decision point by just 20%, we can have a huge impact on the bottom line. And there's definitely a lot of information that can be gleaned from the previous phases that is not being systematically considered yet. And in my vision, ZONTAL will support a laboratory where all the data is prepared in a way where these type of decisions will become feasible and where people can be really driven by their data instead of by some gut instinct. Okay, so that's overall where we stand. Obviously, the field has made rapid strides. We all heard the FAIR data acronym so often, I don't even have to spell it out for this group. But basically what we have seen over the last few years working with our customers is that while the IT has understood that FAIR data is a great idea and lots of business stakeholders are supportive of it, the execution of data transformation projects lacks somewhat. And the core problem of that is shown on this slide. So what we find in many laboratories today is that they have all of the standard instruments that are producing data, but some IT project in the past decided that we can just take this data and push it up into the cloud. And then we have it in the cloud, we call it FAIR because it is findable and accessible. Internet probably reusable, we don't quite know what that means, but probably because the data is there and people can get it, so it's probably it. And so these IT projects have been done, data was pushed in the cloud, but when you look at what the business does nowadays, they're still looking at the instruments and the folders in their local file shares, network drives, where these instruments are producing data and grabbing information from there. And so there's kind of these two parallel worlds, because the initial experiments that were, initial rollouts were done with just some subgroup of the business, and it never got quite the adoption. And so one of the core problems that I think is impeding right now our customers to make, or not yet customers, to make good data-driven decisions is that data that has been verified and put somewhere is not leveraged. And so maybe a KPI that you've heard before that I really want to caution against is judging the success of your digital transformation simply by the number of instruments that are connected to the cloud and how many petabytes you might have in your silo. What you really want to think about is what are the number of successful requests that have been made against this data hub, so that the number of successful insights can be counted by the business. And I think that those two numbers are not always the same, and that can help really with identifying what type of application will bring the biggest benefit. To make this somewhat academic explanation more tangible, let's look at a concrete example of flow cytometry. So flow cytometry is by itself a rather simple experimental technique. You prepare a sample, you put it in an instrument, you get some raw data out and you analyze it. But if you go through the process that goes behind it in a common biology laboratory, you will see that there's a massive amount of manual work involved. And so people typically start out planning out the experiments. Maybe they have an Excel-based sheet. They start putting out, what type of blockades they're going to use, what type of concentrations they're going to use. They plan it out. After they're done on the Excel sheet, they make a local copy of their file into their network drive, and then they go to the instrument. Now, the instrument doesn't know what to make of that plate map that they have used before, so they have to key everything in again to make sure that the data that's acquired is written out in raw data that has at least some file name with it that makes sense, which is then put into some hard drive. Those hard drives that are connected to the instruments are typically limited in their storage capacity. So there's oftentimes an IT project connected here, which will put the data out either into a data backup or maybe into one of these FAIR data cloud silos. The data is just being pushed away, but the scientist typically doesn't care about that. He still grabs the files from the instrument, copies them over into their personal network drive, and then starts the expert tool session. And so they might use FlowJo or some other tool. They key in the information from the Excel sheet again. They find the right raw data files. They start compensating, they're gating, and then they do their analysis, whatever they do there. Now, this takes them some time and they don't want to lose their work. So they create in between snapshots of the work session. These work sessions are again stored in the network drive. Eventually, they come to something that they deem a good representation of their data. They copy it over into a PowerPoint presentation. And then at some point, once that is finally analyzed, they create a PDF report that might go into an ELN, or more often is shared via email with one of their colleagues. So you can see there's a bunch of these little hands shown here, because there's so much manual transcription necessary along the way. And that's really how it happens today at the majority of the laboratories that we're interacting with. Now, what I would like to focus on is, after this PDF has been created and shared, how does the person that receives it deal with that? And so if we think about the person receiving such a report, let's say it's a colleague, a different flow cytometry user at a different site that is wondering about a specific cell line. And he requested this report, he gets it via email from his colleague, and he looks at it and is asking himself, what the heck is going on in this report? Because if you have dealt with certain techniques, you will see that there's a lot of flexibility in how to analyze these files, especially in flow cytometry. You can, compensations, gatings, there's a lot of variability in how you analyze data, so you might not always be 100% sure that it was done correctly. So what options does a different scientist have now? He can either accept the PDF and the findings that are in there, or he can start to try to reproduce them. And how would he go about it? Well, there's the local network, there's the cloud, so maybe he can find the data. More often than not, he will not be able to find everything together, so most likely he's going to send an email to his colleague and say, hey, would you be able to share with me the plate map where you planned this whole thing out? Maybe the colleague went on a vacation over the long weekend, so the next week at some point he gets the email, and then he has the plate map. So he has an idea of what type of raw data he should look for. Then he goes to the instrument trying to find it, but the instrument by now had all of the data pulled into the backup because the hard drive ran out of space. And so now he has to send a request to IT to get the data. They by now have a ticketing system in place, so it takes them again a while before that's responded to. So maybe another week later, he gets the raw data. Having now the raw data in the Excel file, he can put it into his personal drive and start an expert session. He uses a different tool than his colleague, so his Flowdrill license has expired. He has to renew that. That comes with some cost and some overhead, but eventually he's able to do it. So he's able to start an expert session, load the data in, do the comparison, and then realizes maybe there were some decisions his colleagues made that were not quite what he would do, but overall it's approved, and he can go ahead and use the data about the cell line for what he actually wanted to achieve 3 weeks ago. Most scientists are not willing to do that. And what we see is that instead of going this round, they rather say, you know what, I'm just going to repeat this experiment. It takes me 1 day, and then I know for sure that it was done correctly. And this is obviously an inefficiency that we have to get rid of. And so in this moment, the ZONTAL solution starts that wants to do its best to overcome these challenges. And just to bring you on the same page here, when I talk about ZONTAL, we're talking about an enterprise platform that is able to standardize and harmonize data from all type of workflows. Within that framework, we're offering solutions that specify on specific business cases. And today I want to focus especially on the biology solution, but the overall architecture maps similarly into chemistry and into other verticals. And so by definition, ZONTAL is a fair data hub, which means it's able to connect to any type of data producer. Here's some experiments shown, but you can also envision ELNs, LIMS, whatever is having data can be connected to ZONTAL. And within the ZONTAL platform, we are able to use our parsers to convert the data from whatever instrument into a vendor agnostic format. And this is really the moment where we're leveraging what comes out of the Allotrope group. We're using the Allotrope simple model, we're using the Allotrope data format. Depending on what data set it is, we use the representation that makes most sense. Once the data is in that format, it can be brokered to any other end user that wants to do something with that data. So for example, an expert tool session can directly connect to the data that comes out of a flow cytometry instrument without having to go the route of downloading manual transformation and whatnot. ZONTAL is able to broker that to make sure that the data gets as fast as possible with as little manual work is necessary into the system. Okay, so that's overall the architecture layer of ZONTAL. To understand how this little magic wheel here works that puts data into a standardized format, I want to do one more architecture slide that demonstrates how information flows, for example, from a raw data acquisition system, an instrument, or from a database, from some cloud storage, or through an instrument, maybe through an application like a LIMS or so that comes with an API. All of these can be connected directly to the ZONTAL ingest pipeline. We have file watchers, we can integrate with databases, watch the cloud, or do API integrations there. The data that comes is then put through our pipelining, and inside of the pipelines, we're able to aggregate information and align it. And during this alignment process, we can leverage things like the Allotrope Foundation ontologies and other public ontologies or reference master data systems from the customers to make sure that all the data and metadata is understandable. And after that has been aggregated, we put it in a vendor neutral format, maybe the ASM, maybe the ADF, and then enter it into our multimodal database. And at that stage, it's possible to find the data within the ZONTAL user interface, or to use our APIs to integrate it directly with an end user, or to use some of the applications I'm going to talk to you about in a second. Like any platform that wants to be fair, we have to make sure that users can find their data very quickly and effectively. So here are some snapshots of the user interface from ZONTAL, and I think I've shown this at a few previous Allotrope Connect, so we don't have to spend too much time going through this. But effectively, what we have enabled our users is to take any of the metadata fields that was extracted and made searchable, so that you can very quickly put together a custom interface where you can find the data sets that you care about. And so you can add filters, you can do breadcrumb search, you have free text searches, and you can very quickly identify that one data set that you're interested in. And once you have found it, then really the question is what you're going to do with that data set that you have identified in the cloud. And I think this is really the place where the differentiation of ZONTAL from any other cloud IT solution begins, because in this moment we're saying just having the data in the cloud is not enough. We want to now take the application that their scientist cares about and put it right next to the data in the cloud. And so bringing the application to the data is the new paradigm under which we work, which is the opposite of putting the data to the application, which means downloading it from the cloud, loading into your local expert system, and then doing whatever you do with it. And so all the data that is inside of the ZONTAL system is effectively one click away from a visualization or analysis. And I want to show you in the context of flow cytometry what that really means. So for this, we dive now into the discovery biology solution and the different applications that we have built within it. Maybe as an overview first, within this space of discovery biology, there are lots of different data flows that we encounter at our customers. There are test requests, the instrument integrations, you have the flow cytometry, cell line developments, plate readers, microscopy. And for all of those, I'm going to give you some insights, but my main focus is really on the flow cytometry, which is the main product that we're launching at this point. So let's take a look at it. The first thing that ZONTAL does is it eradicates all these manual processes that we have seen before. So instead of having to go from planning out an Excel sheet and then keying everything into your cytometer, the representation from the key map is already being converted into an Allotrope simple model. And then that model is brokered back into the flow cytometer so that you do not have to put again the names for the different experiments, the conditions in the wells and whatnot, and manually. And that way, the raw data that is being produced is already of higher fidelity. You already have your channel names correct. You already have your concentrations correct. All the metadata in the FCS files has been updated to highest degrees of fidelity. And that can then become, again, an ingested asset within ZONTAL. And from here, be automatically pulled into the expert session, so that even if someone in the future wants to relaunch any analysis, that can be just done with a click, and you don't have to go back and try to find some raw data somewhere else. And then also the data that comes out of such a session, so they call it workspace files in the flow drawing example, those are then again made entries within the ZONTAL database so that you're able to work with it. And for that, we had to build new data models, right? So plates have to be represented as a data model. The individual wells have to be the raw data that comes out of the flow cytometry. Workspace files have to be. And so for this, we have developed a set of data models that we're using. And those are all potential candidates for allotrope governance. So that's something we can maybe discuss at a later point how that might work out. But overall, we're really trying to find a way to make sure that all of the assets that are being created in such an experiment don't come with any vendor hooks, but they're completely agnostic and anyone can use them at any point in time. You can plug an API against the data and use it in whatever context you prefer. What we have found, though, is that just having the data inside of the cloud is not enough. And so if you, for example, look for your flow cytometry experiment and you find it within ZONTAL, you open it up and you see here the contents. So there's some experiment, there's some flow draw data, so the workspace files, there's some planning data, the Excel sheet, or maybe a CSV file, and then there's the raw data, a bunch of plates, and each of these plates contains a lot of wells. It's nice to have it there, but if you want to do a quick quality control check, or if you want to validate that an image inside of a PDF that your colleague has sent to you is a valid analysis, you don't necessarily want to say, now, okay, I found the data, now I want to download it and put it somewhere else, especially if you're dealing with maybe 300 to megabyte large FCS files. That's quickly annoying to wait for the downloads and integrate it somewhere else. So what we found with our customers is that it's really useful to now have an application that sits right next to the data. And so what we have done is we put a little button next to these entries on which you can click, and that opens up the ZONTAL flow cytometry data viewer. And that will give you this view where you will see a plate that is collecting, in this case, 96 wells in one plate view. And you have a drop down here where you can toggle through the different plates. You can click on any of the wells, and the moment you click on it, ZONTAL automatically loads all the data that is required in order to visualize first the information within the well, and then also align that together with the planning data and with the analysis data. So in this case, we have an analysis view here that has loaded the raw data. So in this case, an FCS file. It gives you the ability to toggle through the different channels that are there. And then you can see two-dimensional, one-dimensional histograms. But you can also activate a view of the gating that was done. And here we found that the scientists that are using this really benefit from being able to just click into it and see right away what are my populations, how they were gated, and how are the compensations applied in this context. And so for the ability to take a PDF report and not only have a static image in there, but a link underneath, you click on a link and you go directly into such an interactive viewer, you have, if you can achieve that, you really bring a lot of business value right away to your business stakeholders that are interested in not only verifying data, but really getting reuse out of it that helps them make good decisions. Okay, one step further, we can aggregate over multiple experiments. And so this is a flow cytometry dashboard that shows that once you have data within the system, you're not limited to only viewing individual files, but you can quickly do quality control. And here the use case was that the group created hundreds of these analysis files, but they were kind of like an integrated Excel sheet. And when you wanted to do plate level quality control, you had to open up 96 of those and put them next to each other, which is a really painful process. And so when the data is ingested into ZONTAL, though, you can very rapidly configure a dashboard on top of it. And that's really, again, the power of having data inside of a vendor-neutral format like the Allotrope format. It doesn't matter what type of flow cytometer was used. If the data is standardized, you can just put any application on top of it that visualizes it and allows you to do cross comparisons. And so instead of having to open these 100 of Excel sheets, you get a nice heat map, you have interaction, you can look at different channels and very quickly assess if all of these experiments were done with the same fidelity, or if at any point you might have had a blockage in your cytometer or some other issues experimentally that should have been resolved. In that biology solution that we have, there are not only supports for flow cytometry, we also offer supports, for example, for plate readers. Here are some graphical impressions of how plates can be integrated in these dashboards and rapidly connected to different raw data streams that sit in wells that are, again, through the data models that we have intercollected. So you can click on any well and it automatically brings up the data that belongs to it. You can have, for example, image files. So here, this is from a cell seeder that are linked to different wells. So you can very quickly do a rapid rapid quality control on those type of images. You can also compare it with data. This comes from a cell metric system where you can make nice plots or graphs depending on what type of data you want to overlay. In this case, you can select multiple wells and quickly see how trends differ between them, and that can help you with your initial data analysis even. Other systems that we have integrated with are called icon systems, but there's just a whole slew of those that we can very quickly integrate with. And then this, I guess, is a good representation of flexibility. The data model that we have created does not only work with 96 well plates, but any dimension of plates will be supported. So depending on how you like to store your data or how the data is really captured, the visualizations can be configured to bring the best business insights. One thing I'm pretty excited about, because I like to work with AI, is an integration here with the CDEX system, where it's about identifying different cells or colonies of cells. And in this case, the main question that people have is, what's a viable cell? What's a dead cell? But then you might also ask yourself questions about mitosis of cells, surface blips, and those type of more granular and more finely granular analysis that is not easily done with statistical tools can be achieved with some of the new image algorithms that are around, leveraging large pre-trained data sets in the deep learning world. And so we're excited to integrate those into these analysis viewers so that when you click on a data set, at some point, you actually get more information by looking at the data in the ZONTAL system than on the acquisition software that you had. And thereby you can start annotating data with more metadata that doesn't require expert analysis, but can be automated. And that way, hopefully, we can start to power some of that decision-making process that I mentioned before that aggregates over lots of different experiment types to help them to provide summary views and dashboards that really help understand the whole product and where it's going. This goes further. We have a lot of different image supports. So for example, for ViCell data, it's shown here. Another graphical impression would be on this slide, where we see some whole slide images or high-resolution microscopy images. ZONTAL has been set up in a way to manage all of these data streams. We leverage whatever vendor-agnostic format is best suited for these cases, so ASM, ADF where it makes sense, and other image formats where they make sense. Overall, it's been a very interesting journey over the last 1.5 years to see how data that was once verified can now be turned into really powerful assets by us adding this application layer on top. And so going forward, I'm really interested in working with all of you together to create all of the tools that are necessary to empower our scientists to make the type of decisions that bring them out of this chaos that oftentimes exists around data today into a world where great amounts of data inform our decisions and help us put better products faster to the market to help more people. Of course, this is not possible by ourselves, so we are very happy about all the great collaborations we had, also with many of you in the room. And so integrating is always something that's easier when we do it collaboratively. And so we try to foster really the spirit of collaboration and integration. And so we're grateful for everyone who's worked with us together so far, and for the Allotrope organization to invite us again today to speak here and give you an insight of what we have been able to do not only with regards to putting data into the allotrope format, but then to really bring business value into the biotech world. So with this, I'm at the end of my presentation, and I thank you so much for your attention.